Hello and welcome to this webinar, this exciting webinar. My name is Syed Ali. I am very fortunate to be here with Atif Khan and Dan Cruz. We have a great topic and a lot to cover today. Atif Khan is a CTO and co-founder at Alkira. Dan Cruz is network architect at Koch Industries. Dan Cruz has been doing networking for over 20 years now. 5 years ago, we met at Koch Industries. Dan has lots of notable accomplishments at Koch Industries. He's deployed global SD-WAN deployments for over 650 sites, designed and deployed Koch's data center backbone, designed and deployed Koch's first cloud on-ramp actually as well. And we've had a luxury of working with him. Atif, did you want to add anything?
Yeah, thank you, Syed. Dan, it is a pleasure to have you on this webinar with us. And I can start with giving a brief history of how we met Dan and for our audience. So it was I think Dan, just correct me anytime if I'm mistaken. It was early to mid 2015 when Koch started evaluating different SD-WAN vendors, and Viptela was one of them. And so they ended up obviously selecting Viptela for their SD-WAN, global SD-WAN deployment at that time. And then when Amir and I started Alkira back in May of 2018, we engaged with Dan and his team. Dan talked to us about the Koch's cloud deployment at that time and the cloud infrastructure that him and his team had built based on cloud on-ramps, and then we shared our vision. Me and Amir shared our Alkira's vision with him. So Koch's team, Dan especially, and his team, they've been building in-house cloud network infrastructure to enable and onboard AWS in different regions across the globe for the last few years. And these guys have a wealth of cloud networking experience. And during the last 2 years, Dan and his team, they have provided us valuable feedback on our solution. And that feedback has greatly helped us build a comprehensive yet simple to use global unified cloud networking platform, which is delivered and consumed as a service. And we call it a network cloud. And with this, I will hand it to Dan to take us through his presentation.
Hey, thanks, Atif. And I really want to start off first by, thanking you and Syed and the Alkira team for inviting me here today to talk about Koch's cloud journey. Some of the things that you were saying there early on really took me back to the early days when we first met in that little Reno office, talking about SD-WAN and the future of Koch's network. So a little background on Koch Industries and who we are and what we do in our enterprise. So Koch Industries is one of the largest privately held companies in America, and we're based out of Wichita, Kansas. There's a number of Koch companies some people might be familiar with, like Georgia Pacific and Molex and Vista, Guardian who makes glass, and Georgia Pacific who makes consumer products, like Dixie and AngelSoft. We also have companies that do ranching and fertilizer, software, data analytics. I mean, the whole gambit really within Koch Industries. We've reinvested a significant portion of earnings into the business in the past 6 years and made nearly $30 billion in technology-related investments alone. I specifically work for KGS or Koch Global Services. We're the managed service provider for all the different Koch companies. There's 7 global networks that we maintain for Koch, over 19,000 network devices that we manage. We're in 70 different countries, roughly 700 remote locations, and thousands of applications. So as you can see and tell, we're a pretty large and complex organization. Going back to where this all started, 5 years ago, 6 years ago, as Atif was saying when we first met, the enterprise was really a traditional enterprise. We had MPLS circuits at all of our remote locations, all of our traffic backhauled to our on-prem data centers in Wichita and Green Bay. Remote sites had small T1 circuits and DSL lines for backup. I mean, very small traditional network capability. And we were really a limiting factor for the businesses. The businesses were asking for SaaS-based applications and to transform the way that we were doing things. And the timing was ideal, really. SD-WAN was new in the market. The network technologies were changing. So we had to sit back and think, how do we go from being a limited factor or constraint to being a force enabler, right? And what does that mean? What does the future of Koch's network look like? And we thought about things like, the internet is the network, identity is the perimeter, any device is a work device, and really cloud is the data center. Well, what does that mean? Cloud is the data center. So initial thought was, hey, let's move our applications to SaaS-based applications. We were grounded in reality by the application teams fairly quickly that not all applications can become SaaS-based applications, that some of them have been around for quite some time, and it would take a while to refactor them. So what does that mean for the network? Can we at least become more agile and move things into a private cloud or move things to AWS, who's our preferred cloud provider? And how do we provide connectivity to those different cloud providers that are out there, like Google and Azure and AWS? So we started thinking about data center transfers, application requirements, latency, bandwidth, all of those things, and how do we connect to the cloud? We came up with 3 different kind of versions, and we knew that we wouldn't be able to get to the last one for a while because we didn't really see anything in the market that was capable of doing it. The first version, and really our thoughts around the first version were, we have all of this data in our on-prem data centers, and we have to get it into the cloud. So how do you do large data transfers to the cloud? And there's a number of ways to do that. We chose to bring in large direct connects and build what we refer to as our transport hub, our physical hub locations, and 4 different locations within the US, with large data center interconnects between them and large direct connects to AWS. We also looked at ExpressRoute with Azure. We looked at co-location facilities, and we did some experiments with co-location facilities as well. It was just extremely complex, not just from a technology perspective, but from a process and people perspective, to manage and maintain contracts and access and all of the things that go into that. And then we thought about, well, what comes next after the physical? And looking across other technologies and how things have evolved, our vision was, hey, really physical virtual as a service is how things should transform within our transport hubs. Start off physical, move to virtual appliances in our cloud providers, and then at some point, hopefully we'll be able to do as a service if it's available in the market. So what did we end up doing for our first iteration? Like I said, we brought in large data center interconnects and direct connects. We spent 18 months from idea creation to actual production implementation. We spent $2 million and over 2,000 labor hours actually implementing all this across just 4 locations within the US. We had to think through who are the right circuit providers to bring in, who are the right cloud providers, how big of a circuit do we start with? We actually started with a 1 gig circuit, and at 3 different locations, and very quickly realized that that wasn't big enough and moved to 10 gig circuits at 3 different locations. What was the right type of hardware to bring in? At the end of the day, we ended up with 4 hub locations, 3 10 gig direct connects, there's 5 10 gig data center interconnects so that we can do large data transfers between data centers as well as to the cloud. We ended up with geographic internet failover. We reduced our MPLS circuits and internet circuits at our hub locations down to a single MPLS and single internet circuit at each hub location, and then we used geographic failover in that space. And what does that look like? So really, here's kind of our backbone diagram, high level, with the circuits that we've brought in, SD-WAN in there, AWS, the different regions that we're in with AWS, and the latency between them. So as it stands today, between our primary facility and headquarters location in Wichita to AWS, we're looking roughly about 45 milliseconds. And that worked for a time being to do the large data transfers. Some of the challenges that we faced with the application team was getting them to think differently about how they do their data transfers, single TCP stream versus multiple UDP streams, those type of things. When you go from an on-prem data center where you have less than a millisecond latency between your back end and your front end to the cloud, and you increase the latency by 45 milliseconds, it really impacts the amount of throughput that's available to the applications accessing the back end systems. So once we completed our Transport Hub 1 initiatives, as well as SD-WAN initiatives, we started looking at how can we virtualize our cloud on-ramps? How do we get things, more capabilities in the cloud? And our businesses were asking us for more capabilities. They were asking for local egress for AWS resources out to the internet directly versus having to backhaul to Wichita or one of our other locations. They were asking for third-party ingress, remote site access. Like I said, our first iteration only had an AWS Direct Connect, and in order for a remote site to access AWS resources, I had to backhaul through one of our data centers. So even a remote site that's sitting in Georgia or Virginia had to backhaul to Wichita in order to go up to AWS. So how do we resolve those problems? How do we reduce the latency and increase the capabilities to the cloud? And so we look to virtualize everything and doing a DIY type capability with cloud on-ramps. It took us about 6 to 9 months to design and test and validate everything before actually implementing for our first customer. The things that we had to consider is really what pieces do we leverage that are native within AWS versus what do we add on? So what vendors do we bring in? What technologies do we bring in? Do we do load balancing? Do we do WAN acceleration? Those type of things. How do we facilitate remote site access for sites that don't have SD-WAN deployed, or do we make SD-WAN a requirement for remote site access? Do we leverage native AWS load balancers, or do we bring in something like F5s? And then what are the limiting factors? So there are some limiting factors that we found out about as we looked to AWS and their native capabilities, even within their transit gateway. The route limitations and the complex routing capabilities just weren't there for us to meet our needs. And so we really had to build some custom things. At any rate, we ended up with 10 cloud on-ramps deployed, specifically to 2 regions in the US. We have about 85 VPCs today that leverage those cloud on-ramps. We spent about 1,000 labor hours building that. we have local egress for AWS resources, we have remote site connectivity, and we have ingress capabilities. So what does this look like? Pretty complex. So we have what we call our transit VPC, and it has 2 Cisco CSRs in there. We land our direct connects on those. It has underlay connections to what we refer to as our security VPC, where our firewalls are hosted and where we have third-party ingress occurring. And then it also has underlay connections to what we call the SD-WAN VPC, and that's how remote sites come in. And then we do multiple tunnels to the transit gateway with ECMP so that we can really take advantage of the throughput capabilities there. Otherwise, we'd be limited to really less than a gig of throughput. I think the max that we get across the single tunnel was about 900 megs when we did our testing. And so at any rate, there's limited resources that can support this model with our environment just because of the amount of complexity. There's really 3 different locations in which a default route can come in, and multiple route maps and policies that are in place to block and deny traffic and route traffic appropriately and treat things the way they should be. So super complex to manage. And limited resources really that have access to this environment, that can manage this environment, make changes in this environment for what we consider some of our most critical applications.
Dan, if I may jump in on the previous one, when you were going out and connecting to your and providing the service into AWS, did you have to do any cleanup on the host VPC side where subnets or there were IGW that you didn't want going direct out and you wanted to go through the transport hubs?
So I would say no. When we started thinking about cloud and we thought about SaaS-based applications, and then we thought about applications born natively in the cloud, and then applications that required connectivity back to Coke. What we refer to as the traditional or legacy VPCs, those have requirements back to Coke's network to connect back to Coke's network, and those were built with no IGWs or anything like that. They were directly connected originally to our direct connects. And so we did have to migrate them over, but there weren't any IGWs or VGWs involved in that initial deployment of those VPCs. And so really when we transitioned them over, it was fairly straightforward to transition them over. I think flipping them over took less than 5 seconds of downtime to do that.
Okay, cool. Thanks.
And like I was saying, fairly complex what we built. Took 6 to 9 months to design and build, and that was only for AWS. If we were to try and do something similar with Google or Azure, we may be able to do it in less than 6 months, but there was certainly some design and testing, validation, lead time that was going to be part of that to add in another cloud provider. And so as the network architect for Coke, I was sitting back and really looking at these designs and looking at what we implemented, and just, it was a lot, a little bit overwhelming on how complex things were. And I think, Syed, that's when, me, you, and Atif started talking about, the challenges of cloud and the lack of native capabilities within the different cloud providers for the complex networking requirements that large enterprises have. I think that was roughly, go ahead.
I'm sure skill set was another factor as well, probably.
Yeah, I mean, even today, right, there's only about maybe 5 people in the network team that really know how these cloud on-ramps are built and how complex they are for Coke, and what all the different things are that go into that and how to make changes without causing an impact.
Yeah.
And I recall, Syed, you came down to Reno, and I was telling you how complex things were and how long it took us, and you were telling me that a lot of the other customers that you had talked to had done exactly the same thing, and had taken them just as long to do it. I had reached out to one of my counterparts at N4, who had presented at AWS something very similar to what we had built. And so definitely saw a need in the marketplace for an as-a-service capability that could abstract the complexity of cloud networking and cloud on-ramps.
Yeah, exactly. And most customers actually were, when we spoke, were at the Transport Hub 1.0 phase, right, where they hadn't even journeyed off to building these overlays themselves, because it's too difficult to do on your own, right? So most customers would have either colos or data centers where they had the physical devices and all the traffic would be hairpinning back to get any kind of firewall services if they needed VPC to VPC communication, and then if it was intercloud, same thing, they would have to bring that traffic back.
Yeah,
and the moment the moment you bring in higher layer services like firewalls and stuff, and integrating those with even with TGW, it just becomes so complicated so quickly. And the complex slide, Dan, that you put up there becomes even more complicated when you have multiple clouds and multiple services and traffic steering policies and different use cases that you're trying to solve with that.
Yeah, I mean, you guys really grounded me in reality in some of those early conversations we were having. I was so proud of what we had done with our DIY cloud on-ramps, right? It was complex, but it was really cool from a networking perspective, being able to do something like that and facilitate it for the business, something to be proud of, right? But then you start asking me questions, right, about, hey, how soon until you go to Azure? How soon until you go to Google? What happens when you want to expand regions to APAC or EU? What other capabilities do you need? And thinking through all that, you really start to realize that the complexity becomes exponential. The administrative overhead and management automation needed to facilitate all that grows quite a bit, especially when you talk about multi-cloud, multi-region.
Absolutely.
Yeah,
Absolutely.
And then building this infrastructure is one thing, and then managing, running, operating all day two operations. If something goes wrong, troubleshooting all of this stuff, having end-to-end visibility between clouds, on-prem to cloud, all of that. It just becomes a monumental effort.
And then I don't know what you think about this, Atif, as well, but what I've noticed is what most customers spend a lot of time doing this and building these connectivity into probably a single cloud. After that, they're very reluctant to actually even entertain the idea of going to multiple clouds, right? So their business may want to go to Google, but it's just they know the effort it took to build up plumbing into a single cloud, that they're really don't want to take the advantage. And so then the business and the enterprises have to force themselves to stick to a single cloud provider.
Yeah, I mean, like the businesses, some of the businesses had come and asked and had thoughts about leveraging Azure or Google, and every time they asked, it was like, hey, it's going to take us 6 to 9 months to figure out how we're going to do that and how we're going to build that connectivity for you to facilitate what you need. And then we started thinking about, data gravity. And how does that impact us if we don't have leveraged or shared infrastructure between the clouds, or agnostic infrastructure between the clouds? Then we'll have to backhaul that to one of our data centers, right? So now I'm incurring 45 milliseconds of latency from Wichita to AWS, but then another 45 milliseconds of latency to Azure or Google in the same region. Okay, so at that point, the Alkira team and Atif and Syed had shared with us what they were working on with Alkira, and so really started thinking about, okay, Transport Hub 3.x as a service. What are the things that Koch needs to go and test to ensure that we can do that? We put a project plan together, and these are some of the things that we thought about. Data center connectivity, AWS Direct Connects, AWS, Azure, SD-WAN, how do we provide that connectivity, what throughput requirements. All of these are the things that we wanted to go and test, and that was about, what, a year ago, almost a year ago today,
Yeah, exactly.
that we went out and and tested these things within the Alkira platform.
Yep.
Okay, and then as we actually were testing and deploying these things into our production environment, some of the challenges that we ran into, right, or some of the more complex things with the Alkira stuff, and I wouldn't even say it was Alkira, it was more just Koch is just complex, right? So we had to build an underlay from our data centers to the Alkira platform. And the complexity really is that we have, like I said, 7 different global networks in 7 different network containers with 7 different routing tables, all on the same device. And so that's really where the complexity came in, but that had everything to do with just Koch's environment and really nothing to do with the Alkira platform. In fact, Alkira, I think you guys provided a fairly concise configuration and design on how we would connect our data center to the Alkira platform.
And just to be clear, this is to extend your direct connect, the existing one, into Alkira?
That's correct. That was to extend our direct connection to Alkira, and it was around that same time where we realized, and I think it wasn't clear, at least to me, when we talked about all the things that Alkira could do for Koch when it came to cloud on-ramps. I didn't realize that our infrastructure at that point, our physical infrastructure, becomes leveraged. So our AWS Direct Connects become agnostic to the cloud. They're connected to the Alkira platform, and we can leverage them to access Azure or Google or AWS across the Alkira platform, which was huge for us, because when we initially looked at our Transport Hub 1 initiatives and bringing in Direct Connects, we were going to have to bring in Azure Express Route as well as AWS Direct Connects to connect to both clouds. Well, now I can share that AWS Direct Connect across both cloud providers, which is a pretty big deal for us. This is just a screenshot of one of our lines of businesses where we confirmed that Alkira was receiving all the routes from that line of business, roughly 8,000 routes. And so one of the things that's always a concern for Koch, because of how large and complex we are, is the scalability and can you handle everything we're going to throw at you. I think we learned a lot of those lessons during our SD-WAN deployment. At any rate, you can see here that we're sending roughly 8,000 routes in one line of business to the Alkira platform. Across the 7 lines of businesses, if I was to add them all up, it's roughly in the realm of 35,000 routes is what I would imagine. So at the end of our pilot, this is what we had deployed, and for the most part, this is still what we have deployed today with a few exceptions. But we had 2 CXPs deployed in 2 different regions. We had Azure connectivity, we had AWS connectivity, we had direct connects, we have SD-WAN appliances deployed, we have PAN firewalls deployed for local egress and ingress capabilities. And the interesting thing is, like I said before, it took 6 to 9 months to deploy to a cloud provider from Koch's environment. We stood this up in less than a few weeks. And in fact, when we wanted to connect Azure for testing with Windows Virtual Desktop, the endpoint team came to us with that request on a Friday. The cloud team provisioned the account on a Monday, and the network team provisioned the network on a Tuesday, and they were up and running. That's how quickly we were able to move, and it only took us those 3 days because just planning-wise, it had nothing to do really with the keyboard structures, change controls, and planning, collaboration, communication, and stuff. That's and more Monday of our was organizational complexity. Well, there's a weekend in there.
Yeah, so here one of the biggest things in the topology slide that you have is extending segmentation right across regions. People, it takes months and much longer if you try to do that in physical data centers or across colo facilities to extend multiple segments. And that was one big thing for Koch to be able to maintain that segmentation end to end. So.
Yep, absolutely. Even in our DIY cloud on-ramps where we have lines of businesses in multiple regions, we have to do BGP peering and VPC peering between the different AWS regions, and that can be painful to manage and troubleshoot when there are problems. And so Alkira doing that for us and abstracting that complexity and simplifying the management is very helpful. It allows us to leverage other resources that may not necessarily have that in-depth technical skill that it would take if you had to do it yourself versus subscribing to a service. We saw the same thing with our security team, right? So we deployed the PAN firewalls. Alkira solved a major problem for us around auto-scaling the firewalls. In our own DIY solution, we weren't able to auto-scale our firewalls, and so Alkira can do that for us. We have flexible firewall deployment and policy creation through the intent-based policy within the Alkira platform. We can redirect traffic to the PAN firewall as needed, or always have it there to address issues, and really reduce the capability or complexity of managing that platform. In fact, one of the security engineers that has been working on the Alkira platform, he's what's the word I'm looking for here? He was an intern last year, and so he's still new into the networking and security industry, but he was able to jump right into the Alkira platform and start managing it, whereas historically with our DIY capability, we had like our most senior engineering resources on that to do the configuration and deployments.
Yeah, and it's awesome working with him. And my favorite part about this is customers can really focus on the security policies, right? And just pushing the policies and then selecting which specific type of traffic that needs to go, and not have to worry about bootstrapping the VMs, worrying about maintaining traffic symmetry, and how do I stitch traffic to the actual instance, not only stitching it and then stitching it on a per business unit or per segment basis. It becomes very challenging, difficult. So I know your team, security team especially, really like the fact that they could just focus on pushing the security policies and everything else is taken care of.
All right, we did some performance testing from our data centers to the cloud through the Alkira platform, and I think it's important to keep in mind that during this performance testing, we were testing to confirm expectation, not max out the platform. We wanted to ensure that the throughput we were seeing, the latency we were seeing was expected, and really what we were paying for as part of the service. And so from our on-prem data center in Wichita to AWS, we're getting 42 milliseconds. As you can see in the previous slides, that's what we kind of expected. We were getting 45 milliseconds before, and really that's just a factor of the geographic distance between Wichita and US East. And then we were getting about 80 megs of throughput on a single TCP stream, which is expected due to the latency. And then when we did run multiple UDP streams with iPerf, we were seeing that we were getting the full capability or capacity of the available bandwidth. We were able to achieve 1 gig of throughput for that testing. And so that really met our expectations. Like I said, we weren't trying to max out the platform. We were just trying to confirm expectation in the service we were receiving from the Alkira platform. We also did cloud-to-cloud testing. And so between clouds, we were seeing 6 milliseconds of latency and over 180 megs of throughput. These are on a single TCP stream between the clouds for testing, really just looking at what we expected to be getting, not necessarily trying to max out or break the platform and push it to its limits. But this in itself was kind of a big deal for us. I mentioned earlier about data gravity and having to backhaul to our data centers if we wanted to connect two clouds together or leverage two clouds. So kind of a big deal when you think about, okay, if I'm getting 180 megs on a single TCP stream, if I change that to UDP and leverage multiple streams, what can I achieve throughput-wise? And then we talk about day 2 operational visibility. These are the things that are available today in the platform. You can see bandwidth utilization, firewall utilization and scale. There's detailed logging, application and policy, troubleshooting. Alkira continues to add functions and capabilities in this space. So moving on. As we look to the future, what does that look like? So as I think about Koch and what Koch needs to be successful and all the initiatives that we want to drive forward with, like I said, we're a fairly large and complex organization. Some of the things on our roadmap are driving away from our on-prem data centers and going all in into the cloud. In order to do that, we have some complex routing capabilities that exist in our on-prem data centers for business to business or cross-container communication. So a lot of these things Alkira can help us with or will help us with. We're working very closely with them. Some of these things we haven't implemented today, even though they're available within the Alkira platform. And that's simply just a matter of Koch's complexity and us having to plan and prioritize when we're going to do that work. All right, so major takeaways and really what I'd like the audience to remember from this talk is that end-to-end deployments for Koch went from months of planning to just weeks and days of planning. Configurations went from hours of configurations or days of configurations down to hours of configurations, and even in some cases minutes of configurations. And then provisioning time really changed. It's very quick, minutes of provisioning time, whereas before, we spent days and hours configuring and provisioning things. Now things are very quick within the Alkira platform. We enabled multi-cloud opportunities within Koch that didn't exist before, really driving demand and business transformation within multi-cloud. High throughput, low latency between clouds, network and security services in the marketplace within the Alkira platform. And then we continue to reduce and optimize our operations through the use of the Alkira platform.
Dan, I got to add here, I love the call that we had one time with you and Mike Worthington, your cloud architect, on the call, and you were debating how fast the network team was, or was the network team faster or the cloud team faster? That's usually unheard of.
Yeah. I said early on that the network was a limiting factor or constraint when it came to business transformation. We just not able to move as fast And then when you have, the endpoint team wanting to do Windows Virtual Desktop, or you have an analytics team that wants to use Google for their analytics capabilities, and we can't facilitate connectivity to a different cloud provider for 6 to 9 months, being able to do that within just a few days is huge. The opportunity cost there is pretty amazing.
Cool. Well, thank you. Was this your last slide then?
I believe so.
Looks like we have a couple questions actually that came in that we can take. We have a few minutes. So the first question is I'll read it out. Is Alkira a managed service provider, and do customers lose visibility and control they've had? Atif, do you want to take that one?
Sure. No, it is not a managed service. So I think it's a good question. We need to clarify that. It's not a managed service, though we have partners who are working on providing managed service to their customers using Alkira's service. So our service, I'll go into a little bit more details. Our service is running on a purpose-built software platform that has been designed from ground up. And it allows customers to build their network using our platform. So you can think of it as, in a way, a network infrastructure as a service. So, building a network is one thing, but then operating the network is another, as I said earlier also. So you need like full day-to operations and functionality and features to operate it. So visibility, monitoring, troubleshooting capabilities are key requirements for our customers, as Dan was also showing it in his slides. And our platform provides all of it. So whether it's application visibility, flow visibility, routing visibility, or controls such as network access controls or application level controls or troubleshooting and monitoring tools. So yes, it's not a managed service, and it's a platform which allows customers to build and operate their network.
Awesome.
Yeah, I would just add on to that, if you don't mind, Syed, as being someone who has leveraged the platform, the Alkira platform. I don't think it is a managed service provider. I look at Alkira as similar to compute would look to AWS, right? Alkira helps facilitate things for us and simplifies deployments and the management pieces. But I still have all the control of how I want to route traffic, where I want traffic to go. All of those things are still controlled by the network team within Koch.
Yeah, awesome. Yeah, and that's the goal, right? To be able to give customers the visibility and the control that one argues that it was hard to get actually without a solution like this.
Yeah.
Cool. Thanks for that. Then maybe the next question you can take was when did Koch start thinking about multi-cloud or taking advantage of other cloud services? Was it during, would you say, Transport Up 2.0 timeframe, 1.0?
I'd actually go all the way back to the beginning. I mean, really, with our Transport Hub 1.0 initiatives, where we built those large hub locations in the U.S. Like I said, we experimented with Azure Express Route because we did see a demand. I mean, our businesses wanted to leverage Office 365. They wanted to leverage Windows Virtual Desktop. They wanted to leverage the native the Windows capabilities that exist within Azure. But it was just so complex and costly to manage an express route, multiple express routes, as well as multiple AWS direct connects, and very complex and very costly is what I would say. And so I'm sure there was other factors that played into it, but from a networking perspective and from a network architecture perspective, for me, it came down to cost and complexity of managing two different cloud providers. AWS is our preferred cloud provider, and so we went that direction and held off on the multi-cloud capability, 4 or 5 years ago when we did our first iteration.
Yeah. Thanks for that. And it looks like we're right at 45 minutes. So we'll take one more question here, and at the floor. Dan, either one of you can chime in on this one. So how familiar do customers need to be with cloud-native constructs when using Alkira?
I'll jump in there. So I did a lot of the initial testing back in the early days of our cloud journey with AWS and Azure, and I had to learn two different constructs, right? Like I had to understand how AWS did its network connectivity and provisioning versus how Azure did it, right? A VPC versus a VNet, what the different capabilities were, how to connect it all. There was a lot of learnings that went on there for me. We had to train our operations team on the AWS stuff. With the Alkira platform, that's all abstracted. You don't have to know the different nuances between the platforms. Don't get me wrong. You still have to be a network person. You still have to understand networking. There are some concepts that you need to learn. But if Alkira had been around, 5 years ago when we did our initial transport hubs, we probably would be multi-cloud today, but we're not.
Gotcha. Cool. Thank you. Atif, would you like to add anything to that?
No, I think Dan summed it up very well. So it's one network that connects all clouds, public or private, data centers, branches, even distributed remote workforce, SaaS applications, internet, etc. And it's all done in one way where all of these are just endpoints. And this is what Alkira makes possible. And you have one network with all these endpoints, one way to connect, manage, and operate this network.
Cool. Thank you, guys. So appreciate it. Looks like we are a little past 45 minutes. So appreciate everyone's time. Hope everyone enjoyed this webinar. Please reach out to us if you have any other questions. Thanks. Thank you, Dan.
Yeah, thanks, Dan, and thanks for sharing your journey with Alkira. I'm sure it's very helpful for our customers, potential customers, and our audience who are listening right now.
Yeah, thanks for having me here today, guys. I really appreciate it, and I love sharing Koch's journey and the challenges we faced along the way.
Awesome.
Thank you.
Thank you.